Hey there. This is section 4, I believe it is, notes section 4. We're still on our little tabs up here, and I hope that you're enjoying the GeoGebra thing as I go through. You can find, you can explore this as well. Just go to geogebra.org and play around and see what kind of stuff that you can create. But I'm going to say goodbye to my face again. And this right here, we're on our third tab. We have circumscribed, we have inscribed. Now we're going to leave circles for a moment and talk about this right here. Now, as I move this around, I want you to see if you can guess how I have created these lines. And maybe you can make a prediction about how these work. And now I will give you a nice big hint. D is the midpoint between C and B. So again, we have taken this side right here, cut it in half, but instead of making a perpendicular bisector like we did in the first tab, I'm going to take this point right here and connect it with the other vertex. So now I have these lines right here, and these lines are called medians. The medians are the lines that will connect a center of one side with the vertex on the other side. And again, they intersect here rather nicely. You might be wondering, well, what can I do with this, this point right here? This point has a name. It's called the centroid. And a name that I like to use for it is actually called the center of gravity. If you were to take this triangle and hang it from this point, it would balance right along this line. Or a better way of saying it is if you were to construct this exact triangle out of some kind of metal or something like that, and you were to find this point right here and put a little dent right there, a little dimple with a nail or something, it would balance perfectly on that point. You could spin it around on that point right there. And usually I do an experiment with that in class with a piece of cardboard, and usually it fails miserably because my detail isn't all that accurate. But this is called the center of gravity. I can't construct anything with it. But what's interesting about this here, this point on the perpendicular bisectors can move outside the triangle. This one cannot, because the circle always has to be inside. Likewise, this one cannot ever leave the inside of the circle because your center of gravity of a triangle can't be on the outside. But what else, the final thing I'll say before this video shuts off on me, if you look at this length right here, it is clearly shorter than this over here, but it's shorter by a very specific amount. If this right here were 10 units, this would be 20 units. This shorter side is half this longer side. This longer side is twice this one. We could also say that of this entire median, the shorter part is 1/3 of it. So if this whole thing were 30 units long, divide that by 3, you'd get 10. The rest of it would be the 20 over here. If this were 5, this whole thing would be 15, and this would be 10. So that's a pretty cool thing. We can use some algebra to figure out how long those different medians are. And I think that's it. We've got one tab left. Stay tuned.